Hello, I am Dinesh and our project is Object Recognition. Team members are Sridhar, Abhaysai, Rupesh and our guide is Mrs. P. Sureka, Assistant Professor, CSE Department. Object detection is basically identifying the objects within the image and interpreting the object localization. Object localization is basically finding out the coordinates of the object in the image. Object detection can be done in various ways, and one of them is creating a bounding box around the object or marking every pixel of the object and processing to recognize it. In this particular project, we have used a model called RCNN, Recurrent Convolution Neural Network, which means the output of the neuron is looped back to become the input of the previous step. It is built for the object detection that combines the features computed by convolution neural network 2. Image classification or image recognition is calculating the probability of an object within the image, and object localization refers to identifying the location of the object in the image. Basically, an object has different properties like color, texture, and enclosure. In this model, all these properties are extracted and classified to recognize the object. And the proposed system, we pass an image to the network and it is sent through various convolution and pooling layers. Finally, we get the output in the form of objects class. First, we take the input, which is an image. Then we divide the image into few blocks, and each blocks is considered as a separate image, and all these blocks are passed through the convolution and pooling layers, in which every block is extracted to find the properties and classified to recognize the objects within the block. Once we have divided each region into its corresponding class, after the objects are recognized, the output is displayed. Advantages. The main advantage of using RCNN is increased accuracy. In the previous system, to recognize the objects, the CNN model has been used, in which different phases such as extraction phase and classification phase are different. But in this RCNN model, extraction and classification layers are wrapped into one to form decreased complexity, and then accuracy is increased, and no expensive hardware is required to run this model. And why RCNN is better? An RCNN is a recurrent convolution neural network in which the output is stored by the model and passes it to the next phase as an input, due to which the model remembers its previous outputs for better performance. In addition to that, RCNN also adds on features computed by convolution neural network also. And in RCNN, different layers such as extraction layer and classification layer are wrapped into one layer to decrease the complexity and increase the accuracy, and to decrease the processing time and increase the speed. Using the RCNN model, we can produce a quality of an image up to 5 FPS. And the system architecture of RCNN. First the image processing, then feature selection, feature extraction, and then classification and recognition. In the first phase, image is taken as an input and divided into different blocks. Each block is considered as image and features are extracted. Then they are classified and recognizes as objects and produces the output. And this is the architecture of the RCNN model. It has different phases such as extract region, compute CNN features, and classification region. All these layers are wrapped to form a single region uh, to decrease the complexity and increase the accuracy. Faster RCNN uh, also improves the processing speed of the model, and the hardware requirements are 64-bit operating system and a minimum of 4 GB RAM, an inter-core processor, and a webcam to take the input. The software requirements of the project requires an advanced Python environment which could run modules such as NumPy, OpenCV, CSV, and Keras, and TensorFlow. NumPy is to perform mathematical operations and run linear regression. OpenCV and Keras are to take the data and process it. And this is the code of the project. In the first phase, modules required are imported, and the output is displayed as shown in the picture. Thank you. Now let's see the execution of the model. Thank you.